So now all we're going to do is factor. We have a whole bunch of examples. So this section combines everything we've done before into one nice pretty section. So starting off, part A, 9x squared minus 9. Remember, the first rule of factoring is to factor out the greatest common factor, which would be 9. If we took out a 9, we'd be left with x squared minus 1. X squared minus 1 is two terms where each term is a perfect square, which means this is a difference of squares. X is being squared to make x squared. 1 is being squared to make 1. So A would be x, B would be 1, so we would say x plus 1, x minus 1 in either order. And the 9 that we pulled out stays there on the outside. Don't forget to write it. So 9x squared minus 9 factors as 9x plus 1, 9x plus 1, x minus 1. Part B. We have two terms. There's no GCF except for one. There's a sum in between it, and both of these terms can be rewritten as cubes. So this is a sum of cubes. So we remember we have that beautiful formula for the sum of cubes. This would factor as a plus b times a squared. Well, a is 3x, so when we square it, we get 9x squared. You have to square the 3 and the x, minus, opposite sign, a times b, 3x times 2 is 6x, plus, always plus, b squared, 2 squared is 4. So that sum of cubes factors as this glorious thing. Fantastic. Part C, 6xy squared plus 60xy plus 150x. Again, first rule in factoring, take out a GCF. We can pull out a 6x. If we pull out a 6x, we are left with y squared plus 10y plus 25. Y squared plus 10y plus 25, you can think of one of two ways. You can say what multiplies to 25 but adds to 10, and you would say 5 and 5. So you can say 6x, y plus 5, y plus 5. Or you can realize that we have the format of a perfect square. Y being squared makes y squared. 5 being squared makes 25. And the inside has the format of 2 times the first times the last. So this would also be written as 6x, the GCF that we pulled out, times y plus 5 quantity squared. So either of these last two lines are acceptable. Part D, x to the fourth minus 16. X to the fourth minus 16 is two terms with a difference in between them. And notice each term is a perfect square. It's x squared squared makes x to the fourth, and 16 is 4 squared. So using the formula for a difference of squares would be a plus b, a minus b. X squared plus 4 is a sum of squares and does not break down any further using real numbers. However, x squared minus 4 is another difference of squares because x is being squared to make x squared and 2 is being squared to make 4. So because of that, we can break this down even further. The first factor, x squared plus 4, stays right there. And x squared minus 4 factors as x plus 2, x minus 2. So, under the real numbers, the final factorization of x to the fourth minus 16 is x squared plus 4 times x plus 2, x minus 2. Let's try some more problems. Part E, x to the squared, I'm keeping that in there, plus 10x plus 25 minus 4y squared. Notice we have 4 terms here. If we tried to group 2 by 2, just watch this, don't write this down. If we try to group this 2 by 2 to do factor by grouping, from the first group we can pull out an x, and we would be left with x plus 10. In the second group we can only pull out a 1, and we would be left with 25 minus 4y squared. The problem is that these two factors that are left over are not the same, which means factoring by grouping did not work. So let me erase that real quick. And typically, if factoring by grouping does not work the first time, what you might have to do is rearrange the terms, like rearrange the 25 and the negative 4y squared, and try it again. Well, if you did that, it still would not work. So 2 by 2 factoring by grouping does not work. So instead, we're going to do 3 by 1. I'm going to group the first 3 and keep the minus 4y squared where it is. The reason why I'm grouping the first 3 is because the first 3 is a perfect square. We saw this earlier. X squared plus 10x plus 25 factors as x plus 5 quantity squared. So now we only have 2 terms. The first one is x plus 5 quantity squared, and the second term is 4y squared. Well, we have a difference of 2 squares. So this factors yet again as a x plus 5, that was my dog Lucky, plus b 2y. The reason it's a 2y is because 2y quantity squared makes 4y squared. So a plus b times a x plus 5 minus b 2y. So this factors as x plus 5 plus 2y times x plus 5 minus 2y. Part F is similar. We're going to have to do 3 by 1 factoring. The thing is that we keep the 64 x squared as is, but the 3 that we're going to pull out is the last 3. Notice I'm going to factor out a negative 1. And if I factor out a negative 1, I will be left with 4y squared minus 4y plus 1. The reason to factor out the negative 1 is because it's very hard to factor when the leading coefficient, in this case this negative right here, this negative 4 namely, is negative. So it's better to pull out a negative 1 instead. Okay, the 64x squared copies down, minus 4y squared minus 4y plus 1 is a perfect square. 4y squared is 2y being squared. 1 squared makes 1. And notice the inside has the format 2 times the first times the last. So because of that, this does factor as a 2y minus b 1 squared. So yet again, we have 64x squared, which is a perfect square of 8x, and 2y minus 1 quantity squared, which is a perfect square of 2y minus 1, which means we have another difference of squares. So we'll factor yet again to say 8x plus 2y minus 1. So a plus b. And be careful with this next part. 8x minus 2y minus 1. A minus b. Those parentheses are needed. Why are those parentheses needed? Because the b is more than one term. So we can distribute through that negative, and we are left with 8x minus 2y plus 1. For part G, we have 4 terms yet again, but good news, normal factoring by grouping works. So if I group the first two and the last two, from the first group, we can pull out a 3a, and we would be left with 2a plus 1. And the second group, we can pull out a b, and we would be left with 2a plus 1. Since they both have a 2a plus 1, that becomes the GCF. And we would be left with 3a plus b. So there's the factorization in part G. Lastly, in part H, notice that both terms have a factor of x plus 5. So if we were to take out that x plus 5, from the first group, we would be left with x minus 3 plus, in the second group, we would be left with x minus 7. Cleaning up that second factor, x minus 3 plus x minus 7 cleans up as 2x minus 10. But remember, to factor means to write as a product. 2x minus 10 has a factor of 2 in it. So if we pulled that 2 out, we would be left with x minus 5. Now that 2 I pulled out, I could put in front. I'm going to put it right here. And then I'm left with x minus 5. So sorry that that's squishy. But the final factorization would be 2 times x plus 5, x minus 5. And lastly, for this section in part I, we have 4 terms. Let's group 2 by 2. The first group, we can pull out p, and we would be left with p squared minus q squared. In the second group, we can pull out q, and we would be left with p squared minus q squared. They both have a p squared minus q squared, and we would be left with p plus q. Well, p squared minus q squared is a difference of squares. So this breaks up as p plus q, p minus q. And the p plus q that we had before just comes on down. You could leave it like this, but since these two factors are the same, you could combine them with a square on the factor. Technically, either of these two last lines are correct.